Okay, so we're going to be calculating a new question for limiting reactants as an example. Okay, we're going to calculate where we have 100 grams of oxygen reacting with 111 grams of butane. Here's the chemical reaction we're going to follow. And notice in this question, we're looking for how many grams of water. So water will be the unknown material. You really do need to be able to identify the unknown when you're setting up your work, because that's your goal. That's what you're aiming for. Water is the unknown material. We want to know how many grams of it. Our givens will be oxygen one time, and the other given will be butane, and we'll use that with a different calculation. So we have two givens. We'll use one of them at a time, and we will compare the answer to find the true answer when we're done. Okay. So I've copied the equation to my paper so that when I write bigger, you can still see everything. All right. We're going to start with 100 grams of water. Oh, this time the question says grams. So you know we're going to need the molar mass of water, oxygen. The molar mass of oxygen, it's O2. So we'll do the atomic mass of oxygen. We'll multiply by 2 because the formula tells us to. And when we need it, the molar mass of that is 31.998. We did that in the previous lesson, which was on grams to moles, grams to grams, excuse me. Molar mass, gram per mole, there we go, there's our unit. Grams per mole is the unit. Okay, we also will use the molar mass of butane. Let me just give you that number. When we do C4H10, we found this in the previous class. It was 58.124 grams per mole. That was the unit when we did it before. Same numbers today, it's the same chemical. All right. So I've got my molar masses. Let's just calculate one question at a time. We will calculate grams of oxygen first and find out how many grams of water will be made. We're looking for grams of water. That's our question. Okay. In our answer, do we want grams of oxygen in our answer? Whoops, it's supposed to be a 1 here. Okay. No, we do not want grams of oxygen in our answer, so we will put grams of oxygen here to make it cancel out, won't we? If we follow the foldable, okay, what goes on top of grams of given? It's going to be moles of given, isn't it? Okay, so we'll put moles, and the given this time is oxygen. Grams of given on bottom, moles of given on top. Any questions at this point? Okay. Now, do you want moles of given in your answer? Do you want moles of oxygen as your answer?
No.
No. So we need to cancel it. Moles of oxygen is not the unit I want in my answer. I have to cancel it. So if I copy it to the bottom, it will be canceled, just like you do with numbers in algebra. Okay, but according to the foldable, okay, I've got moles on the bottom for the first time. This is the mole ratio step. You got moles of given oxygen on the bottom. We want moles of what on top? Moles of what will go on top? We're looking for water. So that, yes, it's the unknown, yes. So moles of unknown will go on top, and the unknown is water.
Yep.
You saw that it was water? Okay, very good. So moles of water will go on top. Okay. Moles of given on bottom, moles of unknown on top. Moles of unknown, unknown is water. That's why we write moles of water. Questions? Okay, I hope I'm explaining it very clearly. Okay, do you like moles of water as your answer?
No.
No, okay, at least you've got water, but that's not right. We don't want moles of water. We want grams of water. So that means we need to copy moles of water to the bottom, right? Moles of water has to get copied to the bottom. Okay, and at this point, okay, moles of unknown, water's the unknown. We can now finally get to grams of unknown, can't we? And unknown is water, so when we write grams of water, we finally made it to the answers unit that we're looking for. We want grams of water, we finally got there. Because at the top, at the end, we have the unit we want. This will be where the calculation stops, and we'll put an equal sign. Of course, we need the numbers, but we'll do that now. Okay, grams of water. Do I use 22.4 or do I use a molar mass of it?
Molar mass.
Molar mass. And I will tell you, if you do H times 2 plus O, you know, the atomic masses, you'll get 18.015. That is the molar mass of H2O using the atomic masses from the periodic table. 2 hydrogens and an oxygen. Are you okay with that? All right. What number goes on bottom? A 1. Okay. True. It's always going to be a 1 there. Always. Just like the foldable says. Okay. We go to moles over moles. What numbers do we use there? Coefficients. So look at water. What is the coefficient on water? It's 10. Don't worry about what the number is. Just read what the equation says and copy it. It's a 10. Everybody sees it's a 10? Okay. What is the coefficient on oxygen? Go to the equation. Yeah, it's 13. Oxygen has 13. Does everybody see why I picked 10 for the top and then 13 for the bottom?
Mm-hmm.
Coefficient says use, the foldable says use coefficients on the mole ratio. Got them. Questions? Okay. On the top, what number goes on top?
1.
1. That's what the foldable says. It says put a 1. That's what we're putting. Always. If we use this step. Okay, grams of oxygen. Do we use 22.4 or do we use the molar mass of it?
Molar mass.
Molar mass. And just to save a little time, I gave you the molar mass of oxygen at the start. Okay? So 31.998. Any questions where I got 31.998? You see how I got it. Okay, we're now ready to calculate. Okay? And I will point to the number as I put it in my calculator so you can follow along. You can even do it yourself. Okay, 100 times 10 times 18.015 dividing by 31.998 and dividing by 13 equals, okay, you see how at the beginning there are 4 digits, 100.0, that's 4 digits. So that is why I'm going to keep 4 digits here. And it's going to be 43.31 when I round it properly. The 0 is followed by a 7, so 43.31. And the unit, just like you saw before, the unit is from here. It did not cancel. And so we want grams of hydrogen as our unit. Excuse me, grams of water. There we go. Grams of water is the unit of our answer. But are we finished? No. We have a second calculation to do and then a decision to make. So we're getting close. And the second calculation is actually kind of similar to the first one. So that hopefully lowers your stress level a little. Okay, this question starts with grams of butane. And I forgot to write the 1 underneath the given. It's always a 1 there. Okay, let's make it work. Do we want grams of butane in our answer? No. So we have to copy it to the bottom, don't we? All right, so grams, oops, don't forget the unit. The grams of butane, C4H10, that goes to the bottom. All right, what is the unit for the top? Moles of, right, C4H10, I hear you, good. Moles of C4H10. Do we want moles of C4H10 as our answer? No. So we copy moles of C4H10, we copy it to the bottom. Moles C4H10, copied to the bottom. What do we want on top now? Moles of unknown on top, right? We have moles of given, the C4H10, we have that on the bottom. Now we want moles of, what was the unknown? Water. Right, because water was in the question. So moles H2O goes on top because it is the unknown. Any questions? And we're following the foldable. We have moles of given on bottom, moles of unknown. Okay, but do we want moles of water as our answer? No. So here we go again. Does it get copied to the bottom or to the top? To the bottom. So moles of H2O will go to the bottom so that it will cancel. Okay. What are we looking for? Grams of water. Yeah, we want grams of water. Grams of water. So grams of water will be the last thing we write in our calculation. And this will be the point where we stop and we can hit equals once all the numbers are in. Any questions how any part of this is set up? And we're getting ready to put numbers. Any questions? All right. Let's do it again. Grams of water. Oh, we had grams of water. It's the same number. Water's water's water. So what's the molar mass of water? Yeah. 18.015. It's exactly the same number we had earlier. Everyone's okay with that? All right, that's the molar mass of our unknown. Okay, now what number goes on the bottom? A 1, just like the foldable says. Go backwards a column. Where do these numbers come from? Coefficients. Look at the equation carefully. What is the coefficient on water? 10. It's just like what we saw before. It's still a 10. Okay, water still gets a 10 on it. All right, what is the coefficient on butane now?
2.
Yeah, it's a 2, right from the equation. Butane has a 2 on it. That's why I'm using it here. All right, just a couple numbers left and then we can calculate. What number goes on top?
A 1.
A 1. The foldable says a 1, you put a 1, always. Okay, then we have grams C4H10. Am I going to use 22.4 or am I going to use molar mass? Molar mass. So that's when you would have had the periodic table, atomic masses, and you calculate C4H10. And we have already found that to be 58.124. We did that in our previous class on grams to grams stoichiometry. Mass to mass, grams to grams. Okay. Now we're ready to calculate that answer, aren't we? So let's just do it. Okay? Calculator clear. All right, 111 times 10 times 18.015 dividing by 58.124 and dividing by 2. I'm ignoring the ones so we can hit equals. And the calculator says 172. And that'd be grams of water, of course. Now, compare the answers. 43.31 or 172. Which one is correct? The bigger one or the smaller one?
Smaller.
The smaller one. So, just neatly, however you want to do it, make an X and cross out the bigger answer so that you will never accidentally use it as the answer to a question. It is not a true calculation that can even happen. You don't have enough oxygen to use all that butane. It will never happen. This is a lie. It's the wrong answer. Okay, let's go back and let's find out what the limiting reactants are, what the excess reactants are. We can fill in these questions. Okay, what material is the limiting reactant this time? Tell me again, I'm
Water.
sorry. Oxygen, yes.
Oxygen.
So, here's the correct answer. You go all the way back to the beginning, and look who is there. It's oxygen that was there, isn't it? It's oxygen's fault. Do you want to think of it like that? So, since oxygen made the smaller answer happen, there's our limiting reactant. Okay? There's our limiting reactant. Okay? Who is the excess reactant?
Butane.
Right. We go back to the beginning, and you said butane, I believe. Very good. Butane then, since we go back to the beginning, that's the excess reactant. Okay? We have way too much butane for that much oxygen. So butane is the excess reactant, and oxygen is the limiting reactant. Let's write that on our paper. The limiting reactant was oxygen. And we'll go ahead and put Y, because oxygen made, was it the bigger answer or smaller answer? Right, it made the smaller answer. Okay, what is the excess reactant? We said butane, C4H10. Okay, because C4H10 made the larger answer, right? Period. That's it. Any questions? Maybe you thought of something to ask that I didn't realize might be a question. Okay, so I hope these 2 videos will help you with calculating your limiting reactant questions. And please let me know if you have questions.